This is a panel we kind of tried to get a stab at already like earlier yesterday, but we didn't have enough time. So I think there's more things that needs to be said. And I want to start this panel by asking you guys, we're gonna need you to try to speak like you would probably speak to not a 5 years old, but let's say maybe 15 years old kid. Because often, even me, I ended up like having a hard time to follow you, and even if we're facing like this kind of issue all the time at Crash. So that's it for the intro. These guys are building the infra of everything that is going to be private and that needs compute. I want you guys to start by an intro, what you guys are doing, what's your position in the project, and then I think start with a few questions. We can start with you, David.
Hello, everybody. My name is David Snyder. I'm one of the co-creators at Lit Protocol. It is a distributed key management network, so developers use it for custodying private keys for signing transactions, as well as encryption keys for securing private data, which we'll talk a little bit about. The network currently manages just north of $100 million in crypto assets and has secured about 50 million pieces of data for Solana apps, for Fox News, for many Ethereum dApps, and others.
Congrats, guys.
Yeah, hi everyone. This is Marvin. I am the co-founder of Phala Network. We provide key infrastructures to space, include AI agents, AI infras, AI models, and like focus on Ethereum block building space. So yeah,
You define team.
yeah, T is just imagine like a black box running inside servers or your local equipment that you can run secret programs in it, and the other party can verify what's happening there. In the meanwhile, all of the programs can keep secret. Yeah.
Okay, thanks.
Hi everyone, my name is Kyle O'Brien. I'm the chief of staff at a company called Zama. We're an open source cryptography company working on a technology called fully homomorphic encryption, or FHE for short. This technology allows you to run compute over encrypted data without ever decrypting the data. And I guess to put it in terms that a 15-year-old would understand, we enable developers to write confidential smart contracts.
Hey everyone, I'm not Tristan. I'm Juan Angel, ecosystem growth lead at Nillion. And at Nillion, we're building what we call the blind computer, which is essentially a private privacy layer that you can apply to any crypto or Web2 application to compute on confidential, proprietary, sensitive data in a way that never jeopardizes it, never leaves your custody. So yeah, that's what we're doing.
Thank you. Yannik?
Yeah, hi everyone. I'm Yannik, CEO and co-founder at Arcium. And with Arcium, we are building the encrypted supercomputer. And what it enables is for on-chain apps to have confidential functionality, so developers can expand their existing apps to provide privacy to levels and beyond levels than what we've seen in Web2. And at the same time, it becomes possible to use our network as well in an entirely off-chain environment. So you can just communicate with this network, send in encrypted data, and get back encrypted outputs without anyone ever in between seeing what's happening. And the core cryptographic protocols that we're using rely on so-called secure multi-party computation, MPC. Our goal essentially is to eliminate all single points of failure, to get rid of any trust requirements and instead provide privacy in a decentralized and trustless way to enable data ownership, just like blockchains enabled value ownership.
Thank you, Yannik. So we have here really the best project in the field. Like you guys are leading the field in the different tech that you have. There's different type of techs. Maybe you can comment what's the difference between the different protocol, but I don't want to get into that because it's going to get very technical, and I know you guys are going to go there. Each of the techniques can enable different use cases. Some guys want to go for speed, some guys want to go for more privacy, some guys want to go for quantum resistant, for like thinking like 50 years ago, but that's not where we're going to go today. I want to go in a much simpler thing. The question is for you, David, how, and so it's very general, how privacy work on Solana?
Yeah, I mean, Solana is a public chain. I can talk from our perspective, which is how teams use Solana and Lit Protocol for user-owned data. And in most cases, typically the flow is if somebody has some data asset, let's say they want to sell it in a data marketplace, or let's say it's some personal data like their address or social security number, they encrypt it to the distributed key. Then the output of that, of what they have on their computer, something called a ciphertext, an encrypted blob, that then is stored somewhere. Could be on Solana, could be on Arweave, like we just heard from Nirmal in the last chat. They use Lit protocol in their Chakra Drive product. And so in their case, that information is stored on Arweave, I believe. And then the way that Lit interfaces with Solana is that user then sets something called an access control condition, which says certain state needs to be true on Solana for somebody to decrypt that data. So that could be something like they own a given NFT, they own a certain amount of assets, they're a member of a DAO, and then the process is they go, I own this NFT, I have the right to this data. They make a one-to-many connection to all of the nodes of the Lit protocol. Each of those nodes then verifies against the Solana blockchain, does this person have access? And if yes, each of those nodes then sends a piece of the permission down to this person, let's call her Alice, who then aggregates those pieces of permission, those pieces of authority, pulls the encrypted data, the ciphertext, down from wherever it's stored, and decrypts it on her machine. And so this is a process called identity-based encryption, where Lit protocol is this distributed network for managing the access in this context.
Nice, thank you. That was very clear. It makes me think about multi-sig is kind of working. In that case, you try to have several nodes validating your right versus something.
Yeah, I mean, it's definitely the right mental model of like a T of N setup, except a multi-sig is something that is happening in the context of a smart contract. What's different about Lit protocol is threshold cryptography. It's a threshold at the level of the secret itself.
I didn't understand that part of the Patricia.
Like the private key that is being used for the encryption or for the signing, that is the thing that is split into parts. Whereas a multi-sig says we need 3 or 4 private keys to perform some action.
Okay, thank you so much. Lit protocol covered, we understood. Arcium, Yannik, how do you guys enhance the privacy for the Solana user application?
Yeah, so maybe I can give you a quick history about Solana and privacy on Solana. So we started building privacy on Solana 3 years ago, and back in the day on Solana we didn't even have any syscalls for zero knowledge proof verification. So back in the day we were building out CK cryptography in order to verify zero knowledge proofs on top of Solana, and now over the last few years, we've spent significant amount of time together with Solana Labs and now ANSA, who are building a new Solana validator to add even more cryptographic primitives to make it easier to access privacy, encryption, and more different kinds of signature schemes. What Arcium offers developers is to run any kind of functionality in an encrypted way. So you could imagine it as a private smart contract. What does a private smart contract entail? Well, it entails that users can have sensitive data, can have private data, and can interact with this smart contract as if this smart contract was a normal public smart contract, but nobody sees any of the data. And what it enables developers to build is, for example, building dark pools. So in TradFi, nearly 60% of daily US spot volume nowadays isn't publicly being traded on exchanges, but instead in dark pools. So there's large financial institutions like JP Morgan that create those dark pools where they basically have a private order book. People hand them their orders, they privately fill them, and at the end of the day fill their remaining orders publicly on the exchange. And that allows everyone trading on those dark pools to have less slippage, to be able to move larger asset balances without directly impacting the market. And something like this isn't possible on a public blockchain, right? Because everything you do on a blockchain by its nature is publicly exposed to everyone. And there's advantages to this, but there's also this need of adding privacy, both for DeFi, but also for applications like Crunch is building, right? Being able to train AI models in an encrypted way while settling via a blockchain to make systems entirely trustless. So the way we go about it is Arcium being its own dedicated network but not a blockchain, but instead a purely computational network. And this purely computational network uses secure multi-party computation to process encrypted data. And how the flow works is that someone has their smart contract with some encrypted functionality. We've built a custom Rust compiler for this to allow developers to just write normal Solana smart contracts, and within those smart contracts simply specify, I want this to be confidential, I want this to be encrypted, and then automatically the compiler compiles the smart contract and basically into two parts: the normal public smart contract components and the encrypted confidential components. And whenever a user calls an encrypted confidential function, what happens is there's a CPI, a cross-program invocation, that is being sent from their smart contract to the Arcium smart contract, which then gets simultaneously picked up by the Arcium network, and the Arcium network is then able to process whatever the computation has been defined as in a private encrypted way and settle the verifiable output back. And what developers can build with that is they can build applications where everything is encrypted, but they can also build applications where they specify, hey, after some computation has been finished, let's say some encrypted trade has taken place, I want the output to be public, because then there can be a public activity that's being performed on chain. Or they can specify, I want some information to be encrypted for some third party to be viewable. So let's say someone is building this kind of trading exchange and they want to add some level of compliance. And so that's something that we've also done together with Solana for the confidential token standard, where there's an auditing key to which you encrypt so some third party can audit whatever trades take place. And so developers can play around with all of these primitives without having to know anything about cryptography. They can simply specify, this is a public key and I want this public key because this is party XYZ to have viewing access or to be able to execute some confidential functionality. And that makes privacy composable, right? And that's one of the key aspects of Solana, this kind of composability, and that's what originally brought us into Solana, building through the darkest phases of Solana and adding privacy, because we believe in this mission of having composability and being able to just add privacy to the places where privacy is needed.
Thank you, Yannik. Make me think about a use case we see also in TradFi, which is OTC, for example. If you want to place an order, then if this order is very large, you don't want this order to be public, right? You don't want everyone knows that you're about to do this large trade. You're a large bank, you're a large institution, and if you try to do that on chain, then everyone will know that this is about to happen. Maybe know your exposure, maybe know what's happening, in your institution, and that's not feasible. Thank you, Yannik. Next question is from Nillion. In your case, again, for 15 years old adolescent, how do you empower user privacy and data privacy at Nillion? What's the particularity? What's your take on that?
Sorry, could you repeat that last part of the question?
It's pretty general. It's like, what's your take on user privacy in Solana? How do you guys solve that with your particular?
Yeah, great. So I'll add a little bit to the history lesson that Yannik started. Actually, Arcium talks a lot about this concept of privacy 2.0, which I think is a great way of framing it. For those of you who are in the room, maybe this is a newer concept for you. You may be familiar with the first iteration of crypto privacy, which was mainly focused on financial rails. So you could have mixers like Tornado Cash or Samurai Wallet. You could have Zcash, or you could have Monero with ring signatures. But basically, all of this was just focused on obfuscating the sender and the recipient and the transaction taking place. This is a crypto transaction we're talking about. Now, we're moving to this new iteration of crypto privacy 2.0. We talk a lot about white space, and we call it that because we are able to tap into new use cases that were not previously possible, either on Web 2 or on crypto in isolation. So one of the things that is very interesting about crypto is we figured out the crypto economics incentive component. The problem is we've applied it to really stupid games of musical chairs and things like that. But if you can take out the crypto economic incentives and you can apply them to real world use cases that produce some sort of outcome that is beneficial to real people, then it becomes a very interesting thing to examine. So, for example, at Nillion, we're very much focused on the idea of your data it should be private because A, it belongs to you, you generated it, and I think you should, this personal opinion, view it as private property rather than as a human right. But then going beyond that, when you generate this data, not only are you losing out on your humanity by giving it away or having it taken from you without your consent, but you're also missing out on revenue opportunities. So right now, whether you are aware of it or not, there are people buying and selling your data. You create a digital footprint every day. There are data brokers and markets that exist for this in Web 2. And you probably don't have a say in it, and I doubt any of you were paid out anytime recently for any of your online activities. So, with these cryptoeconomic incentives, what we can do is by giving people full custody over the data, I mean, they are the only ones who have encryption and decryption keys for the data they produce. We can then create protocols on top of that utilize these cryptoeconomic incentives to get people to take specific behaviors or partake in specific things. So this could be, for example, using one of our founding entrepreneurs on Nillion called Monatic DNA to privately do genomic sequencing. So you have a version of 23andMe that's actually privacy preserving, where you are the only one with access to these results. And then you can lease out these results to, for example, medical research companies, pharmaceutical companies, anybody else who might want to buy that data without ever actually exposing the underlying data itself or who it belongs to. And simply letting these companies perform computation and getting outputs based on the inputs you've shared and making some money from it, right? Because if you've ever taken the 23andMe test, there are other companies, this is a verifiable fact, that have paid millions of dollars to access those data sets. And of course, we've had other problems like leaks and a lack of conscientious data management from platforms like that. So long story short is by enabling privacy and giving people the option the option to use privacy preserving applications, not only do we give power back to them and make them sovereign in the same way that not your keys, not your coins applies to crypto, not your keys, not your data applies to this new world we're in, but we also give them the opportunity to make money from that data. So that's what we're doing here at Nillion.
Thank you. The next question is about TEs, because we heard about it a lot. You at Phala Network, one of the most amazing, I believe, TEs framework. Can you tell us about it, what it is used for, how it is different from the other tech that we have here?
Yeah, first of all, this is my 5th year working in TE, and the first 3 years is miserable. It's very hard to sell. If you say, hey, we provide privacy, there's no way people will buy it because of it. But in general, first of all, we choose TE because it's practical and high perform, high ROI, friendly to Web 2. But I'm a believer not just for TE. I'm a believer a mix of different cryptographic solutions together, through FHE, MPC, ZKP, blind compute, whatever. All of these technologies should be used together. So I'm pitching to someone to onboard TE, I always say, hey, if you can run a smart contract on Solana to drive your idea, do it. Don't use TE. And if you can run something with FHE on PC, don't use TE. But TE is kind of like a very friendly glue type of technology that can merge all of these cryptographic solutions together. So, and everybody, just pick up your phone, you have TE in your pocket, right? While you're unlocking your face, to your iPhone, or you're, insert your fingerprint to log in Binance, with the pass key, you're already using TE. So this technology already kind of well adopted among all of these smart chips in the world. And how we use it is basically based on 2 features. One is privacy. It can provide confidential alerts. For example, Binance, I'm unlocking my Binance account by using my Face ID. Binance, as an application, it doesn't know how my face looks like. It's pretty handsome, right? But they don't know because the sensitive data of my raw data of my face is already stored in the security enclaves. So Binance only know that, okay, Marvin is unlocking, this account, which is matching with the previous setup. So it only knows 0 and 1. It doesn't know the raw data. So this is basically how TE can provide privacy. The application only can request the data issued. The second killer feature of TE is verifiability. So actually, the AI hack, right? A lot of AI agents and AI infras using TE, not because of confidentiality. They use it because of verifiability. So how it works, the typical case, right?
Can you define verifiability as well?
Yeah. So for example, right, like if you are running an AI agent on Twitter, right, it keeps posting all the time. A lot of people actually ask me, is XBeat the agent, really that smart? Sometimes I feel like it's like a human or some smart operator behind the account and do the posting. It sounds really like human.
So API.
Yeah. How do you know it's really coming from AI? You don't know because AI is generative. Even though with the same computer, same program, you give the same input, every time it generates different output. So you can't validate it. So the only way to make it work so far is to put it in a TE box. And the TE box will tell you, okay, this AI output is generated from this hardware, from this Docker, from this program, so that you can verify what's happening in the AI. And this is autonomous AI. So in TLDR, this is the how we use TLDR.
How does it integrate on chain? You didn't mention the on chain part.
Oh, yeah.
Of the team. How do you put that on chain?
Yeah. So the on-chain part is kind of like I'll break down a little bit. So for example, you are building let's say AI file or FAI, I don't know. Like AI agent can interact with your money, with your funding. You're sending some money to the agent controlled address. It's kind of related with on-chain. But in that case, it's very kind of flexible how the agent running inside TE interact with. For example, you can use NPC like Lead, right, to control to make sure the agent doesn't control the solo key. It has some small consensus to release the funds. So it's very easy to insert something like client, RPC nodes, or APIs inside TE, inside the agent program, so that you can always interact with on-chain securities. And another thing is how you can attest, this program running inside TE. How do I know it works as it should be? We use on-chain attestations. So we actually use some ZK to generate a ZKP for the attestation prover coming from this TE hardware, and we upload this ZKP to layer 1s so that you can always attest the attestation will be used for other smart contracts. So this is how it works.
Nice. You want to add something on TEs?
Yeah, I was going to say you made the strongest case against TEs there, which is that CZ from finance doesn't get to see your handsome face on your devices.
Yeah.
So, Kyle from Zama, you guys are pushing one technology called homomorphic encryption. You are one of the most advanced at it now. Can you tell us what it is exactly? What does it bring to this whole stack of privacy that is unique about it?
Yeah, so at Zama, the first product that we have released is called the FH EVM, which probably gives you a clue as to what ecosystem we focus on thus far.
Yeah.
We do plan to expand into Solana. It's on the roadmap for 2026.
Nice.
So that's very exciting. Anatoly is actually an investor, so we've got some
Nice.
some stake there too. So I want to echo kind of what everyone here said, which is blockchains are really bad at keeping secrets, and I think all of us here are in the business of bringing private, sensitive, confidential data on chain. And the really big unlock here is an entirely new design space, something that you couldn't do previously on a public blockchain. You can now do, and that is across a number of use cases, including DeFi, governance, voting on chain. Think of things like decentralized AI, hiding weights or queries. You can really think of any use case that involves some sort of sensitive data, and you can now bring that on chain. In fact, we're starting to experiment with what it might look like to run a country on chain, for instance, like putting public or civic infrastructure on chain, things like voting or company registries. Look, I think just to echo what everyone said here, there's a number of different privacy preserving tools. We've got MPC, we've got ZK, we've got TEs, we've got FHE, and I think it's going to be a combination of all of these tools that are going to get us to a really interesting place in the blockchain ecosystem.
Okay, what is unique about homomorphic encryption? I want to know that. I want to extract that. Can you tell us the 15 years of math? What is?
Yeah. Well, as I said at the beginning, homomorphic encryption allows you to run compute over encrypting the data without ever decrypting the data. So effectively, you can store a piece of encrypted data on chain. You can run compute over it without decrypting it, so you never reveal the underlying data, and you can give a response back that is also encrypted. So the compute resource that did the computing has no idea what it's computing on, but is able to give you a viable response. So yeah, like I said, it opens up an entirely new design space, and it's fully composable as well.
I have a question for all of you. So we are about to put data, countries, very like sensitive data on chain. What's the risk? Don't answer that. I can feel you. What's the risk of doing that? Like, is data being encrypted one day? How do we reverse? How do we go back?
Yeah, I mean, certainly quantum computers are a risk at the end of the decade, early next. If you have an encrypted data that's in public, that's not quantum resistant, somebody could save that with the intent of decrypting it later. The other risk is a little bit less of a technical one, but more of a product one, which is like, do people want privacy? There's kind of a long-standing idea around privacy isn't a feature. Like, iMessage is far more popular than Signal Chat. And so I think, like, although we're establishing private foundations and there's just phenomenally interesting technologies, like we run threshold MPC inside of TEEs, the focus for sure is how does the privacy preserving technology provide that 10x better experience for the user, largely through composability, largely through like some of the work that we're doing with the agent wallet stuff around being able to store your private data and your private keys and grant abilities to agent runtimes to make transactions on your behalf and use private data on your behalf. Like, the risk is losing sight of the end user and the utility and the benefit and just building privacy for privacy's sake, I would say.
And in that spirit, what are the most exciting use cases that you guys are coming to see? Because now that the technology is maturing, we can start using your different protocols and different things. What are the most exciting use cases? You mentioned putting CD on chain. That's amazing. I kind of want to talk about it. And why would you want to put a CD on chain? What's the interest behind that?
Well, I'll talk about two different use cases. So we can talk about kind of what we call the state OS, the state operating system, the idea of running a country on chain, and the other is just institutional option.
Micro. Okay. Micros. Yeah.
Hello. So the first is around running a country on chain, and the second use case is around institutional adoption, which I think we're seeing more and more of, especially in the past year. If you want to bring big banks or hedge funds or institutional investors on chain, they're not going to want to reveal their positions to the public. It's just not going to happen. So I don't think we're going to get the wave of institutional adoption that everyone is expecting until there is some level of confidentiality. So that's number one. The use case around like state OS, like are we going to get like existing governments like U.S. government to build applications on chain? I think there's a non-zero probability that will happen. But I think there's already countries that are doing this. I was in Buenos Aires at the end of last year, and they already have a ZK identity application that they can use. I used it to access one of the crypto hubs there. So people are already experiencing
It's a national experimentation?
It's a city-based implementation. So you provision basically a state-sponsored identity that's a ZK proof. Which is super cool. I got one for myself. It allowed me to access certain buildings when I was there for the event. You've probably heard of the network state, this kind of concept of people building cities and countries kind of from the ground up, first principles, with kind of blockchain crypto native, something like Vitalia, or what's now called Infinita, which is in the jurisdiction of Prospera, and Honduras is doing this. They have their own currency. You can pay your taxes in Bitcoin. You can take out loans and buy property there using crypto lending protocols. So people are really starting to experiment around all these kind of primitives that exist in kind of legacy code of government and bringing them on chain. So I think we'll get a mix of kind of new countries, new jurisdictions that are experimenting with this from the ground up, and then kind of legacy institutions looking to adopt it because it's going to be where what people want.
Yeah, it's a great question in terms of like, what is the dreamy use case? What is the super file thing? For me, both privacy, this is a conversation about privacy, and also brings in the conversation of, do we end up with decentralized or, quote, open AI or closed siloed AI? And I just don't see a path towards getting a decentralized collective intelligence, which would be a massive societal upgrade in terms of the data exhaust that was talked about earlier. It's not too hard to imagine some of these technologies properly implemented, where as somebody's moving throughout their life in our digitally mediated society, the information that they are passively generating is part of a collective intelligence where their privacy is maintained and secured. And so I don't think we get there without privacy technologies, and we also don't get there without blockchain and open technologies, because the alternative is like siloed, corporate captured, controlled. We have the Apple world, or the Google world, or OpenAI world, and you opt into that. And privacy technologies and decentralized technologies really are the only alternative to not ending up in that captured state. And like, we can talk about the doom and gloom and all the scary things associated with the corporate capture of machine intelligence, but then there's also some pretty beautiful societal outcomes that could happen, and things like collective intelligence, global cybersecurity threat detection, things that just like materially raise the quality of people's lives just by virtue of the fact that they are existing and opting into these systems.
Yes, it makes me think about a use case where maybe some investor could share their portfolio without really sharing it, but then you only get the composition of the key portfolio that can give an alpha that is the composition of the key portfolio, for example, in finance or whatever businesses, their accountants can kind of combine and try to only extract. You can share your accounting to get the output without really sharing it. That's why you mean it's super interesting.
Yeah, and to resonate that point, you really have to grasp this concept, because what we're talking about here is performing black box computations. So what it means is that every single one in this room has some sensitive data. If you look at healthcare data, for example, you have your patient file, but those patient files in the status quo, how our healthcare systems function, sit in isolated silos, right? So we have this valuable data that sits in isolated silos, and this data sits in isolated silos for a reason, because of data breaches, because of privacy concerns. And by being able to perform black box computations, by being able to take all of this data securely, all of this data fully encrypted, training AI models, and having those AI models themselves remain fully encrypted, and then using blockchains as incentivization and coordination layers to train those encrypted models over encrypted data and run inference into those models, again with very sensitive data. That's what this kind of technology enables. And what we've been doing at Arcium in that regard is last year we've acquired our largest Web2 competitor, who've been doing exactly that for healthcare, TradFi, and defense, training highly secure AI models over sensitive data with no risk of leakage, no risk of some hardware being hacked. And so I think that's this big concept that we are moving towards, and that I think actually the biggest intersection as well between AI and blockchain. Being able to decentralize AI, being able to bring ownership back to the individuals, and create this, I think you put it nicely, with collective intelligence, right? Having collective intelligence that belongs to everyone, but nobody actually can grasp it and take it for themselves. You can just access it through a smart contract, I guess, again, fully encrypted.
Yeah, it feels like there is like knowledge that is fragmented in all these silos now, that if we could do things like sharing our data without sharing it and do some common compute, we kind of break these silos. And healthcare is a very good use case, because a lot of the healthcare companies or even countries are sitting on a pile of data that they are not processing. If they could put that together, they have some amazing use cases. Thank you so much. That was a very interesting closing point. 30 minutes is really, really too short. Like every panel, I'm finally getting into the interesting part, and I have to stop. Okay, thank you so much, guys. Yeah, big round of applause for these guys because they are building the really